What's up everyone, welcome back. Patrick here, moving on to the next example, next video. So we've got to simplify each of these expressions. So notice they're all terms dealing with exponents. Get some more practice simplifying exponential expressions. So starting with number one, we got x to the 3, y to the negative 3 all over the 4th root of z. And then all of that is to the power of negative 4. So first thing I'm going to do is I'm actually going to take this 4th root of z. I'm going to change that to a rational exponent, z to the power 1 over 4. And then this y to the negative 3 I'm going to bring down to make it a positive. So we'll have y to the 3 at the bottom now. So the exponent turned positive. And then we'll have z to the power of 1 over 4. And then we got the negative 4 on the outside. Now, within the bracket, notice nothing is going to simplify here. So what we can do now is work with the outside exponent. Notice it's negative, so we have a fraction to the power of a negative exponent. It means we could flip the fraction. And now that exponent is going to be positive. And then what we could do is we can take the numerator to that exponent and the denominator. So we'd have y to the 3 z to the 1 over 4 to the power of 4 all over x to the power of 3 to the power of 4. And then these two terms are multiplying. So we can take both of those terms to the power of 4 since that exponent's on the outside. So we'd have y to the 3 to the power of 4. Then we'd have z 1 over 4 to the power of 4 all over x to the power of, these I'm going to multiply. This would just be 12, like that. And then we can multiply these two. This multiplied would be 12. 1 over 4 times 4 is just 1. Z to the power 1 is just z. And we'd end up with that right there. So we have y to the 12, z to the power 1 all over x to the 12. So that is the answer for number 1. Let me write the answer over here. So we got x to the 12z over y to the 12th, like that. Now moving on to number 2, we got 3 to the power x plus 3 to the power negative x. And then all of that's multiplied by 3 to the power of x minus 3 to the power of x times 3 to the power of x minus 3 to the power of negative x. So here, what we can do is we can distribute this inside the bracket, and then this we could distribute inside the bracket. So what would happen is 3 to the power of x, you could pretend like this is in front even. Right? It was just written over here. So 3 to the power of x times 3 to the power of x, what would that be? Well, same base, we would just add the exponents. We're multiplying two exponential expressions with the same base, add the exponents. X plus x gives us 2x. So that would be 3 to the power of 2x. Over here, we would have 3 to the power of x, 3 to the power of x times 3 to the power of negative x. Right? So this would end up being 3 to the power of x plus negative x, would just give us 0. Which would equal 1. I'm just going to leave it as 3 to the power of 0, just so you could sort of clearly see how we distribute it over here. Keep the basis for now, but that is going to end up equaling 1. And then over here, minus 3 to the x times 3 to the x, that would be minus 3 to the 2x. Same thing as over here. And then this times that, the negatives turn into a positive, and then x plus negative x would give us 0 again. And then from here, what happens is these two cancel out, right? They net out to 0, and then we'll end up with 3 to the power 0 plus 3 to the power 0, which is like 1 plus 1, which is 2. Right? So 2 is the answer to number 2. Moving on to number 3, we got 125x to the 6 all over negative 8 y to the negative 9, and then that's all to the power of negative 2 over 3. So as usual, before dealing with that outside exponent, I'm going to see if we could simplify this inside term. Now 125 over 8, that doesn't simplify. or 125 over negative 8, that actually doesn't simplify any further, that fraction. There's no two numbers that divide 125 or 8 smoothly, the same number that divides it smoothly. So that stays. Now the y to the negative 9 I'm actually going to bring up and change it to a positive exponent. So we'd have x to the 6, y to the power of positive 9. So the negative 8 stayed by itself in the denominator, and then we got the negative 2 over 3. Then from here, what I'm going to do is, because this exponent is negative, I'm going to flip this fraction. So we'd have negative 8, 125, x to the 6, y to the 9, all to the power of positive 2 over 3. Now this negative stays within that term. That's not the negative that changes, only the exponent on the outside changes. Now it's a positive. And so now we have a fraction to this exponent, so we can write negative 8 to the power of 2 over 3. And then we'd have that whole denominator, 125 x to the 6, y to the 9 to the power of 2 over 3, like that. So from here, I'm going to kind of go all over the place. This we can rewrite as negative 8 to the power of 1 over 3 to the power of 2. We could split that rational exponent, and then all of these terms would go to the power of 2 over 3 because they're all multiplying. So the 125 would go to the power of 2 over 3. We'll have x to the 6 to the power of 2 over 3. And then we'll have y to the 9 to the power of 2 over 3, like that. Continuing this here. Negative 8 to the power 1 over 3, or the third root of negative 8, is negative 2. All over 125 to the power 2 over 3. I'm going to split that up. So 125, I'm going to take the third root of that and then take it to the power of 2, just like I did with the negative 8. Now, these two we can multiply. 6 times 2 over 3 would give us 4. So we'd have x to the 4. 9 times 2 over 3 would give us 6. So we'd have y to the 6, like that. Then negative 2 to the power of 2 is positive 4. Then we'd have third root of 125 is 5. That's going to be to the power of positive 2. X to the 4, y to the 6. Then we'd have 4 over 25, x to the 4. Y to the 6, and that's the final answer. Notice there's nothing there that could simplify. 4 over 25 doesn't simplify, and then the x and the y are different bases. So that's what number 3 ends up being. So 4 over 25, x to the 4, y to the 6. And then number 4, there's no variables in this one, so we're going to get an actual numerical answer. I think it's going to be a fraction. So we got the third root of negative 27 over 64. So what we can do, a couple of things we could do. We could actually take that third root and distribute it to the numerator and the denominator right away. So we could rewrite this as the third root of negative 27 over the third root of 64. And I actually might just do it this way, because usually what we're doing, changing it to rational exponents, but we were dealing with rational exponents here. So we could change this to be all to the power of 1 over 3 and then distribute that 1 over 3 to both of these, which would be the same as that. But I'm actually just going to keep it in radical terms, switch it up a bit. Like that. And then we'd have plus, same thing over here. We'll have the fourth root of 81 over the fourth root of 625. This is not 4 times root 81. Maybe make the 4 smaller. It's the fourth root of 81, right? Be careful with that. 4 root 81 is different than the fourth root of 81. So here we'd have the third root of negative 27 is negative 3. Third root of 64 is 4. Fourth root of 81 is 3, and then the fourth root of 625 is 5, like that. Two fractions adding common denominator, 5, 5, 4, 4. We'd have negative 15 over 20, plus 12 over 20. Negative 15 plus 12 would give us negative 3. So negative 3 over 20 ends up being the answer, the final answer for number 4. All right, so a bunch of different exponential expressions that were all in sort of different formats, and then these are the 4 answers.